Yeah, so I was saying we have completed simple harmonic motion, all the parts, including damped, oscillation, etc. Ready to now move on to the next. On Sunday, we'll discuss some additional questions and doubts and discussions if required. So, particularly if you have any doubts from HC Verma in SHM, let's start with those, please. Okay, HC Verma and then the module doubts. Try to complete those. So, just text me the doubts you have in HC Verma or the module. We'll start with the discussion of those. Okay, so let me start by putting up a question, and in the meantime, send me the doubts that you have. We'll discuss this question next. Now we have a spring attached, and this is also fixed to the ground. So this is a block of mass M on a frictionless surface. There's a spring of constant K attached over here to a wall. Okay. Now the system is initially at rest with the spring at natural length. Now what we do is we start applying a constant horizontal force F like this. So initially at t equal to 0, the system is at rest with the spring relaxed. And now a constant horizontal force F starts to act. So given that the spring constant is 40 Newton per centimeter and the mass of the block is 2 kilograms, we'll make it 4 newtons per centimeter. Mass of the block is 2 kg and the constant force we are applying is 3 newtons. So to find the time period of SHM, the amplitude of SHM of the block, and the maximum extension of the spring and the earliest time at which this is achieved. Okay, Samarth, I have received your questions on the text message, exercise 3 and exercise 4. We will discuss those questions next after this. Okay, let's understand the fundamentals of this question first. Okay. Now, at some point of time, let's say now, this has become L plus X. Okay. This is having an acceleration in this direction. So you can understand that 2t is equal to kx. Okay. So t is equal to kx by 2. And for the block, we have f minus t is equal to ma. So f minus kx by 2 is equal to ma. So first of all, you can see that for equilibrium, x has to be equal to 2f by k. So that is and k was how much? It was 4 newtons per centimeter, right? Yeah. So 0.5 centimeters. That is the, sorry, 1.5 centimeters, 3 by 2. That is the extension of the spring at equilibrium. Let's write that as x naught or 2f by k. The extension of spring at equilibrium, which is the mean position. So now suppose this is my mean position. At this point of time, the acceleration is 0. Because T naught is equal to F, and okay. Now from here, let's say the block is displaced further. Okay. So the block is displaced by S. How much will the pulley be displaced by? S by 2. Okay. So the spring's length has increased to L plus X now, where X is equal to X naught plus S by 2.
By 2.
Okay. So now you can see that at this point of time, the tension has become more than F. So it will have an acceleration in this direction, the block. Okay. So we have T minus F is equal to ma, first equation, where A is minus T2S by dt square. Okay. And we have 2T is equal to Kx, which is equal to K into X naught plus S by 2. That's our second equation. Substituting this here, we have K by 2 into X naught plus S by 2 minus F is equal to minus M d2S by dt square. So this equation now has to be compared with this value, that Kx naught is equal to or kx naught by 2 is equal to f. Okay, so we have kx naught by 2 plus ks by 4 is minus f is equal to minus m d2s by dt square. So you got your SHM equation. See, this term and this term will cancel. This term and this term will cancel out from here. So we have the equation that d2s by dt square is minus k by 4m, right? So omega square is k by 4m s. This is your equation of SHM. Now you can also get the amplitude and maximum extension and all by using work energy method, but I want you to try it by the SHM method using phase constant and initial conditions and all that. Okay. I'll also explain it how to get that by work energy method later. Devansh, I think you have sent me some messages with questions, right, of SHM?
Yes.
Yeah, I will discuss these questions also. These are DC Pandey questions, beta, or?
Yes, yes.
Yeah.
Sir,
Yes.
sir, the block will not move backwards, no, again.
No, it will not go behind where it is.
Okay, sir.
Hmm. You know why? No, because it's starting from rest.
Yes.
So in fact, the spring cannot compress. It will only extend. Okay. Now from symmetry, you can understand one thing, that work energy wise, if you think about symmetry, from the starting position where x is 0 till the position where x is equal to x naught, that is the equilibrium position, what is happening? 2t is dominating over kx. So the spring is extending with acceleration, or the block is moving with acceleration. Okay, but at that position, equilibrium position, what happens? The acceleration is momentarily 0. So by then it has gained speed, so it goes beyond that point. Once it goes beyond that point where x naught is equal to 2f by k, the block starts decelerating. Okay, so basically from the starting position where x is equal to 0 till the position x naught, which is 2f by k, what is happening is that the block is accelerating, and beyond that position x naught, the block starts decelerating. So that means, that starting position to mean position, that is the amplitude, no? And on the other side, it will go by the same distance. Understood? So the amplitude of SHM can also be understood that way.
Yes.
Okay, so you will see the amplitude for the block will become how much now? Yeah, Rakshit, I'll scroll up. Okay, see, at the mean position, the spring is extended by how much? It is extended by 1.5. Okay, so going from the initial position to the mean position, the spring extends by 1.5. So the block moves by how much? 3 centimeters. So the amplitude of the block will be 3 centimeters. Okay. The block will go to a maximum displacement from the starting point of 3 plus 3, 6 centimeters. But the spring during that time will go to a maximum extension of 1.5 plus 1.5, that is 3 centimeters. So X maximum will be 3 centimeters, but the amplitude of SHM will also be 3 centimeters. The range of motion of the block will be through 6 centimeters from the left extreme to the right extreme. Okay, so basically, if you consider this in this diagram, that from the starting position, this is not the starting position, but anyhow, so from the starting position to this mean position, the block has actually moved 3 centimeters because the spring has extended by 1.5. So that is the amplitude, and it will go a further 3 centimeters. The spring will go a further x naught. So spring will have extension as 2x naught, which is 3 centimeters. Just a second, people. The whiteboard has gone off screen. I'll get it online.
Yes, sir.
Okay, so now find the time period of SHM first of all. You got omega square, so just substitute the values which are given numerically.
So can you tell what was the value of omega square?
Yeah, just a moment. I'll get the whiteboard online. It's rebooting. Just a second. Yeah, you can see omega square is k by 4m. Okay, and k was how much now? It was 4 newtons per centimeter, right? Yeah, k is 4 newtons per centimeter. M is 2 kg. Yes, that's correct, Samar. Okay, so let's complete this question. So from here we can see that omega square is k by 4m. So that is 4 newtons per centimeter. So we'll convert this. Okay. Block's mass was 2 kgs, I think. Okay, so 100 by 2. So omega is square root of 50 or 5 root 2 radians per second. So time period is just like this. Very approximately the time period is like this. Okay. What happened, beta? Eventually, had a question. Okay. So that's my omega square. Now I know that S is equal to some amplitude into sine omega t plus phi. So we'll find that amplitude and phi. But more importantly, what is the relationship between X and S? Okay. X minus X naught, or basically extension at any point was equal to this plus S by 2. Right? This was the relation. So inverting this, yeah, so we'll just calculate X like that. Okay, now we'll see that at t equal to 0, what was the value of X? X was 0. So that means S was equal to minus 2x naught. Okay, where x naught we had just calculated was 1.5 centimeters or 2f by k. You know, so S's value at t equal to 0 is minus 3 centimeters. That is minus 4f by k. Okay, and again at t equal to 0, the block starts from rest. So from this you can see that at t equal to 0, S is equal to a sine phi, which is minus 3 centimeters or minus 4f by k, and v, which is a omega cos phi, is 0. Okay, so that means phi is minus pi by 2 because sine phi is a negative quantity and cos phi is 0. So 3 pi by 2 or minus pi by 2, whatever we write it as. Okay, and a is equal to 3 centimeters. Okay. So now we've got S as a function of time. If I write it parametrically, it is 4f by k into sine omega t minus pi by 2, which is basically minus 4f by k cos omega t. So that's how I can understand that apart from the fact that amplitude is 4f by k equal to 3 centimeters for the block, omega square was k by 4m, which was equal to 5 root 2. Was it? Yeah. So sorry, omega square was this. So omega was 5 root 2 radians per second. Okay, and all that. Okay, but now I can also see that from this I can understand that x is equal to x naught plus s by 2. as a function of time, right? So x as a function of time. Now remember, what is x naught? It is 2f by k plus s by 2. So from here, s is this. The displacement of the block as a function of time is this. Okay. This is the displacement from mean position of the block, as you can see. So s by 2 is minus 2f by k cos omega t. So extension of the spring, if we use SHM concept to understand it, it is like this. So you can see that the range of motion of the spring is between 0 and 4f by k. Or 3 centimeters. Okay. So this is my x maximum. So the equation of SHM of the block will look like this. It is 3 centimeters into sine of omega t minus pi by 2, where omega is 5 root 2 radians per second. This is the SHM of the block. And the extension of the spring as a function of time will become 1.5 centimeters into 1 minus cos omega t. So hope all aspects of this question are clear. Okay, now I've received a couple of doubts from Samarth from the module. I will start with that. Then questions from Devansh from PC Pandey. We'll discuss those also. So Samarth, the first question you have sent is question number 6 from exercise 3. So those of you who have the module in front of you right now, just turn to page 59, I think, or thereabouts, the module of SHM. There's module number 5. Okay. So there's this question of combination of springs. I'll just bring it up in a moment. Oh, Raji, you're present. I've just received your message. We'll discuss your questions also. Okay, so I'm switching to the module first. Yeah, so Samarth, this is question number 6. Okay, this is the one you have asked, right, Samarth?
Yes, sir.
Okay. So see, effective spring constant we have to calculate. Okay. So basically, you can also understand now the question should actually explain more properly. If I move this in a sort of random direction, then it will have a random sort of motion. But assuming that this is symmetrical, excuse me. Okay. Oh, something is wrong with the question. The value of the spring constant is also not given now. Okay, actually the value of the spring constant should be given somewhere. So we'll just assume all three are same k. Okay, since nothing is given,
Sir,
just
this
assume
is
all.
passage question.
Acha, okay, so there is okay. Let's go to the passage before this then. Yeah. A spring of force constant k is attached with this thing which performs SHM. Now it is cut into three equal parts. Okay. So let's start with this. When we cut a spring of constant k into three equal parts. Okay. So this constant is k and this length is L. This length, okay, the part which is the spring that is of length L. Now if we cut it into three parts which are of length L by 3 each, can you tell me how much will be the spring constant of each part?
3K.
Yes, very good. Okay, it will be 3k. Because if I join these three parts, okay, they'll be in series. So series combination of
Yes, sir.
Ka, Kb and Kc should be equal to k. Okay, so 1 upon Ka plus 1 upon Kb plus 1 upon Kc should be equal to 1 by k, and by symmetry Ka should be equal to Kb, should be equal to Kc because they have equal lengths. Okay, so from that you will get that this is equal to each one is equal to k by 3. Okay, so this is clear to all of you now.
Yes.
Okay, now moving on to the next part. So those 1/3 springs which are each one having a spring constant k by 3, if I've connected like this, okay, so now the system is symmetrical. So assume that we are moving the particle along one of the springs so that there is that symmetry. So like let's say we move it along this, and that too through a small displacement like the constraint question we had done earlier. Okay, so from this position, if I move this by a small displacement x like this, okay, then what is happening to the first spring? It will have an extension of
X.
x. Okay, but what is happening to the second spring and the third spring? They will compress by how much?
Decompression of cos theta. X cos.
Yeah, by cos 60. No? So S2 and S3, they will have a compression of x cos theta. So in this case, cos 60, so x by 2. So now you look at the blocks FBD. When I've displaced it by x, okay, from its equilibrium position. So when I've displaced it by x, this spring is applying a force of k by 3x. Okay, but this spring and this spring, they will be applying a force of k by 3 x prime each. Okay, Devansh, you can handle the question. Sorry, Devansh, you can handle the question. Okay, so Samarth, this question is clear, I hope.
Yes, sir.
What was the next question? But I just lost the messages because I got disconnected. Question 15, was it?
Yes, 15th A and B.
This one, no?
Yes.
Okay, let's go through this. So what is happening? Time period of a simple pendulum having length L. Okay, so that is 2 pi under root L by G. Now, when placed inside in normal circumstances, when inside a lift moving upwards with an acceleration of G by 2. Okay, so when you are inside a lift which is moving upwards with an acceleration of A naught, what happens is that along with weight, there's a pseudo force, no? Okay, so when you go to that position, also the pseudo force acts along with the weight, no? So it's like your effective G becomes A naught plus G when the lift is accelerating upwards. So your time period becomes 2 pi under root L divided by A naught plus G. Now just substitute A naught as G by 2. So you will get this answer. Okay, this is clear, Samar, for A part?
Yes.
Okay. Now similarly, when your lift is going down at G by 2, then what will happen? Your pseudo force acting on that particle will be upwards. So here your effective G will become G minus A naught, which in this case is G by 2. So time period will be 2 pi under root L divided by G minus A naught. So this will become 2L by G. This one. Okay, A and B are clear, beta?
Yes, sir.
What about C and D? They are clear?
Yes.
Okay. And any other doubt you had in the module? One more question you had, no?
Exercise 4, sixth question.
Exercise 4, sixth question. Okay, let's move on. Find the angular frequency of small oscillations of the cylinder containing water. The spring has constant K, pure rolling is happening. Okay. So first of all, we will do this by work energy method because pure rolling is happening. Okay. Or we can do like this also. Okay, I'm just switching to the whiteboard. Now, the only thing you have to remember is that, I mean, you have to keep in mind is that fluid inside a sphere like this, the fluid will not rotate. The fluid will remain static with respect to the sphere. So if the sphere or cylinder or whatever is rolling down, okay, then at that point of time, the liquid inside is only translating. It is not rolling. Okay. So the kinetic energy of the liquid will be pure translational kinetic energy. Whereas the kinetic energy of the sphere, I mean the shell, you know, whatever it is, if it's a cylindrical shell, just I'll check the question again. Cylinder hai. So it's like a hollow cylinder, assume of mass m, and it's containing water of mass small m. Okay. So we will do this by force method only because it's got gravitational potential energy also, so it's unnecessarily going to be very complicated. Just you can see that at some point of time, if this is L plus X, so this is pulling it back with Kx, but other forces are mg sine theta, mg cos theta, normal reaction. Now, if I assume it's accelerating in this direction, then there has to be alpha in this direction, so friction has to be like this. Okay. So I have these equations that mg sine theta minus kx minus friction is equal to ma. Okay. Now this m I'll write as capital M by plus m prime. Okay, I am making the mass of water inside as m prime. Okay. And mass of the cylinder, that is capital M. Okay, I'll change that m prime to m later. It's just easier to write this way. Okay, now friction into radius will be equal to I alpha, and alpha is equal to E by R. So before we proceed, you can see one thing here. So what is going to be the moment of inertia? It is going to be mr square for the cylinder plus 0 for the water. Because what happens, Samad, is that the water does not move. I mean, the water does not rotate with respect to the center of mass of the sphere. The water only translates. Is this concept clear, beta?
Yes, sir.
Whereas if the water had been frozen into ice, then it would contribute m prime by 2 into r square. Okay. So these equations, they will become, you can start by converting this equation. F will become capital mr square by r into E by r. So as you can see, it will become ma, where capital M is the mass of the cylinder. Okay. So substitute this in equation 1. So you have mg sine theta minus kx is equal to m plus small m, which is actually capital M plus m prime. This is your general equation. Okay. Now from this we can see that at equilibrium, k is equal to alpha should be 0 for the sphere. So k should be equal to, I mean, x should be equal to mg sine theta divided by k. So now at x equal to x naught plus s, okay, we have the equation mg sine theta minus k into x naught plus s minus, I mean, resolving all this equation directly I'm writing now, this one. We have 2m plus m prime into a. So this becomes minus ks is equal to 2m plus m prime into d2s by dt square. So equation of SHM for that cylinder with the water of mass m prime filled inside it is this. Okay, this is clear, Samarth?
Yes, sir.
Okay. Now I'm moving to questions from Devansh and Prachi. So I'll start with question from Devansh. So this question is like this, that a particle under the action of one SHM, if it's in under the action of SHM 1, let's say, it has a time period of 3 seconds. And if it is under the action of another SHM, it has a time period of 4 seconds. So if it is under the action of SHM 1 plus 2 simultaneously, then what is its time period? Okay. So we can think of it like this, that suppose we write x1 as, now just to make it simple, we'll keep the amplitude the same, a sine 2 pi by 3 t, and x2 then x is equal to x1 plus x2. So this we can write as okay. Now see, the thing is, here is a product of two oscillating terms. Now this oscillating term has a time period, let's say of t prime, which is how
No,
much?
that's
It is
24
2
by
pi
7.
divided by 2 pi divided by 12. So 24 by 7 seconds. And this term has 24 seconds. Okay. Now it's the product of these two. So this is repeating every 24 seconds, but this is repeating every 1/7 of 24 seconds. So the product of the two are actually repeating at what rate? 24 by 7?
Can you repeat once?
Yes.
See, it's like, if I have the product of two sinusoidal terms, okay, like one term is like this, is varying between -1 and +1, okay, at a time period of, this is the second one, let's say, okay, so it's 24 seconds. But the second one within this is much faster now. In this, it's completing 7 cycles. So let's say I've drawn one where 7 cycles are not getting completed actually. I've drawn one where within this there are how many cycles completing? Okay, I've not drawn an integer number of cycles, but whatever. So suppose this had a time period. So now effectively for the product of the two, this will only become the time period.
Yes, sir.
This time period. So it's like the HCF kind of thing. So it's 24 by 7. So effective time period of the product will actually become 24 by 7 seconds. Okay, so Prachi, the answer to this should be 24 by 7, okay, not 12 by 5. Is the question clear?
Or in the options, this is not there.
Sorry, in the options is not there.
No, sir. 3.43 is not there in the options.
Okay, just a second. Is the calculation we've done correct? Yeah, this is correct one.
Yes.
This is from DC Pandey.
Yes.
Okay. Okay, I will go through the question once more and get back to you, Devansh, about that. Okay.
Okay, sir.
Okay. Now let's come to the next question from the same series. Okay. So in this we have this kind of a situation. These are rigid walls. Okay. And the way the question is given, there are two blocks which are basically like elastic rods. So I will replace the elastic rods with effective springs. Okay. This is the spring P and this is the spring Q. Remember that if you have a rod of length L, area of cross section E, and Young's modulus Y, then the effective spring constant is how much? Ay by L. Okay, this you remember now from the concept of this thing, elasticity, right? So
Sir, I
Devansh, this
got this,
concept.
but my answer was not matched.
Okay. So now my spring constant for P will become how much? A by 2 into 2y divided by L. So it will be Ay by L only.
Yes, sir. Same.
And spring constant for Q will also be Ay by L. So let's take this as K naught. So this is also K naught. So both are having a spring constant K naught. Okay. Now this block is set into motion, moving with a velocity V on the smooth surface. And we have to find the time period for the motion. Okay. So let's say at t equal to 0, it started from here, where this spring is at natural length. But just about it has lost contact. Okay. So when it will reach here, just as it is in contact, coming in contact with this, if this length is L by V, so it will reach here at time t1, moving in this direction at V. Okay. So it will reach here at t1 equal to L by V. Okay. So now it has to compress that spring and come back to its natural position. Okay. So when will that happen? At half the period for such a spring mass system. To come back to natural length. So now it will have a velocity v in this direction. Okay. So यहाँ पे time अगर t2 है, so t2 will be how much? It will be t1 plus half the time period of that one.
Yes, sir, I understand.
So pi by omega, where omega is square root of k by m. Okay. Then it has to go back here. From this point, it has to go back here, where this is at natural length. And this is approaching this at the speed v. So suppose this time is t3. So t3 will be now t2 plus L by v. So that is 2L by v plus pi under root m by k. Okay, clear so far?
Yes, sir.
And now to complete the cycle, it has to come back here, but with opposite velocity. So now it is back to this position. So this is one cycle. So this time T4 is your effective time period. And that T4 will be T3 plus another half time period. No? So effective time period will become 2L by V plus 2 times of this. No? So 2 pi under root m by k. Is the answer matching?
1 minute.
Yeah. So this is similar to actually a previous year JEE question also. but there the springs were of different constants. Okay, so same concept was there.
Yes, sir, it's matching.
Just replace K with this AY by L. So you'll get that answer. Okay.
Yes.
Okay, now let's come to the next one. So just make the diagram. Now it says that we have a block of mass M is kept on a smooth surface and touches two springs. Okay. So touches two springs means, imagine the springs is not attached to it. Understanding? There is a, so what will happen is, for example, when the block moves towards the right, okay, in my diagram, when the block moves towards the right, then the spring K1 will not get extended. Only K2 will be compressed. You understanding better?
Yes, sir.
Whereas when it moves towards the left, only K1 will be compressed. K2 will not get extended. Okay. So T equal to 0, for example, from here.
Yes, sir,
Is
I
the
understood.
natural.
I was thinking K1 will also be attached.
So you have taken equivalent spring constant as K1 plus K2 and done it that way, no? But here
Yes.
what is happening? It's like half a cycle is involving only K2. So that half cycle will have a time of pi under root K2 by M. Okay. And then the next half, sorry, M by K2. Okay. And the next half cycle is only involving K1.
Yes.
This will become your effective. So this is actually just like the previous question only, but there was also a gap in between. So there was that 2L by V involved. Okay, no?
Yes.
So this is an important variation type of question. Okay. Now let's look at the next one. So this is also like a half cycle problem. Okay. So what is happening here is that you have a spring attached to this wall. And this is right now in natural length situation. And the spring is attached to this block. But when it is in natural length position, it's also in contact with this other wall. Okay. So now from here, if I compress and release it, so what will happen? T equal to 0, suppose I release it from here with a compression of x naught. Okay. So quarter cycle later, the block will go and hit the wall, okay, with maximum speed. So this will be at T equal to T by 4. But then instead of extending, because it's an elastic collision, it will directly come to this position. And then it will come back to maximum compression after another quarter cycle.
Yes.
And once that cycle is over, okay. So the effective time period for this will be T by 2. So it's like only the compression part of the cycle is taking place. The extension part is not taking place. An elastic collision, so there's no loss of energy. Okay, Devansh, this is also clear?
Yes, sir. And thank you.
Okay, very good. So these are all your doubts, right?
Yes, sir.
Okay. Now, Prachi, I'm coming to your doubts, beta. Okay, Piyush, I'll come to yours also. Okay, so block is executing SHM on a rough surface under the action of external variable force. Okay, so what should be the... Okay. So basically, see, in general, if you just had a spring mass system, or if you just had an SHM, it doesn't matter what is driving the SHM, but on a rough surface, it would not be possible, no? Because I want the effective force to be restorative. So if this is my x equal to 0 mean position, when the block is going away from the mean position, okay, if this is a rough surface, there'll be spring force, there'll be friction in this direction, and there has to be external force in this direction, so that the net force like this. So F external plus F with proper sign convention has to be equal to minus m omega square x. So this part of the cycle, as your x is going from 0 to a, your F has to be like this. So F external has to be equal to minus of m omega square x plus mu mg. This is from x equal to 0 to x equal to plus a. If I plot F external versus x, so x, as it is going from 0 to a, my F external has to be like this. Okay. Has to be a term like this. Raji, this is clear so far?
So can you explain the RHS term again?
The right hand side, okay. So this is the net force in an SHM now. Net force is equal to minus m omega square x. Because
Oh,
what is the
okay.
action?
So we have considered the friction and F external both together.
Yes, yes. Okay.
Okay.
So F external has to act in such a way that in spite of friction, the net force is restorative and proportional to x. No?
I was taking some opposite to that.
Okay. Now, next part of the cycle, when your block is coming back, its v is in this direction. Okay. But its acceleration should be like this only
Yes, sir.
Yes, sir.
at x. So this time friction is acting like this now. So your F external has to be larger actually. So F external has to be such that so magnitude of F external has to be magnitude of MA plus F. Okay. So effectively this has to be, it has to be the same, is it? No, then something is wrong over here. Wait, something is wrong over here. Let's write this as a magnitude equation first. So F external plus small f is equal to MA. So F external has to be MA minus mu mg, and the direction is negative. Okay. So it has to be minus of wait, so this is wrong. Okay. So the first part, going back to this, for example, when it is at x equal to 0, its acceleration is 0. Okay. But the friction is acting towards the left. So F has to be in the positive direction. So it has to be plus mu mg, and say going like this. something like this. Okay, is this clear now, Prachi?
Yes, sir. This is clear.
Now, like that, when it's coming back, it has to be this kind of thing. F external has to be minus of so while coming back, it is that other one that we had drawn. So with this kind of shape. And now if you just invert this graph on that side when x is negative, so now actually the graph will be what? When x is negative, f has to be in the, like when it's going this direction, f has to also be negative. So this graph will actually continue like this. And
Okay,
then
sir. Got it.
it has to be like this. So what I have labeled as 1, 2, 3, 4 is actually in my diagram, it's starting from mean position. Okay, so 1 is from x equal to 0 to plus a. Then the second part of the graph is as x is going from plus a back to mean position. And third part of it is as it's going from mean position to negative amplitude. Okay, and the fourth and final part will be as x is going from negative of the amplitude to 0. So this you can relate now.
Yes, I will mark the options now.
Okay. Now the next question, very important type of question. Okay. We have to. Okay, Piyush, I will come to your question also. Okay.
Yes, sir.
So this question is like this: that potential energy function for a one-dimensional system is given to us like this: a by x square minus b by x. Okay. So we have to find time period for small oscillation. So now, first of all, for any oscillation, the mean position has to be what? It has to be the stable equilibrium. Right? Understood, na, Prachi?
Yes, sir.
So this is the local minima of the potential energy graph. So it is the point at which du by dx should be 0 and d2u by dx square should be positive for local minima. Okay. So let's start with du by dx, and that will also tell us about the force. Okay. So du by dx is differentiation of this. So minus 2a by x cube plus b by x square. Okay. So the force is minus du by dx. You can also see that the force is b by x square. Sorry, minus b by x square plus, sorry, like this. The net force at any point is and second derivative is 6a by x to the power 4 minus 2b by x cube. Okay. Now let's start with du by dx equal to 0. So we are getting one position x equal to 2a by b. So when you put the second derivative test and all that, now you'll understand that your potential energy as a function of x will typically be something like this. this will be your x0 position, where the potential energy will have some minima. Okay, Prachi, this part I'm not completing the second derivative test, but the concept is clear.
So I got it till here, but what to do after that is what not clear.
Now see, after that what you do is, so you can see that at x equal to x0, your f, which is minus of du by dx at x equal to x0 is equal to 0. Okay. Now we are talking about small displacement. So at small displacement from mean position. So let's take the small displacement as delta x. Okay. So x is equal to x0 plus delta x. What will the force become? Okay. So the force we can write like this. See, f at some point, this is minus du by dx at that point x. Okay. So f at some point x plus delta x will become f at x plus some delta f. You understanding this point, Beta?
Yes, sir.
Now for small delta x, okay, the change in force can be written as df by dx into delta x. Okay, hope this point is clear.
So can you explain that delta f part again? One.
See, what is happening now is from the potential energy graph, if I were to plot the force graph, okay, then at the stable equilibrium point, I would see the force graph is some curve like this. Okay, this is the point x0. Okay. At any general point, if the force is F, then at a point very close to it, x plus delta x, the force should also change by a small increment.
Yes,
Where
sir.
that small increment in force is almost df by dx. No?
Oh, okay, sir. Yes.
Okay, so now see, if I'm taking a small displacement from x0 delta x, then what should be the force at that point? This force delta f, it should be equal to df by dx into delta x. That will only become the net force because the force at x0 is 0. Okay, understood this?
Yes, sir. Sir, I have solved that a bit of that, and in the denominator I get terms like delta x cube. So do we have to neglect that or we have to keep that?
No, wait. We don't have to do all that. Okay. So अभी क्या करेंगे देखो, f we have already got from above, so I'm just writing that here. 2a by x cube minus b by x square. This is my f. Okay, and you can check that f will be 0 at x equal to x0, which is 2a by b. Obviously, that will be the case. Okay. Now, what is the derivative of this force? Okay, it's equal to minus 6a by x to the power 4. Okay, plus 2b by x cube. This is df by dx. Now, what is df by dx at the point x equal to x0? Okay, it is minus 6a divided by x0, which is 2a by b to the power 4 plus 2b divided by 2a by b to the power 3. So how much is this term coming to? Just calculate this once. So we will have minus 6 divided by 2 to the power 4. So that is 16. No? So minus 3 by 8 a cube divided by b to the power 4.
Yes.
No, sorry.
B
to
power
the
4 by A cube.
by a cube. B to the power 4 by a cube. And the second term is going to be how much? 2 divided by 2 cube. So 1 by 4. B to the power 4 by a cube.
Yes, sir.
So ये effectively कितना हो गया? -1/8, right? So this df by dx that we are getting now at that equilibrium position, this is basically what, if you think about it graphically now, you have some sort of a graph between f and x, which at the point x0 is going like this. Okay, but if I take a very small region, you can approximate this as a straight line graph. So for
Yes, sir.
small delta x, okay, for x between x0 plus delta x and x0 minus delta x, okay, f can be approximated as a straight line with slope equal to minus b to the power 4 by 8 aq. So f is sort of like this. It is minus of b to the power 4 by 8 a cube delta x. So this is your effective force constant. So your omega square is your effective force constant divided by mass. So this is your omega, and your time period is 2 pi by omega. Is it clear, beta?
Yes, sir. Now it is clear.
So I'll just generalize this method also, okay, so that it's clear for any sort of potential energy function given. In this case, it was this. Okay. So I'm just taking you through the beginning once more. So this is the concept that any general oscillation can be approximated to a simple harmonic motion if it is having very small amplitude. So let me explain this point again. So when we are discussing oscillations earlier, we saw that what type of system does one-dimensional oscillation? Any system which has only restorative force and its potential energy function should have a local minima. That is, there should be a stable equilibrium point. Okay. So any potential energy graph, irrespective of what the formula of potential energy is, could be coming from a polynomial, it could be coming from this type of combination of hyperbolic terms, it could be trigonometric or whatever. Suppose I have any system where the potential energy graph is like this. It doesn't matter how many maxima minimas and all it has. Okay. So suppose now we are talking about oscillation with respect to this position. So this we have taken as a mean position. And this potential energy is some kind of function of x. So we want to show that with respect to this mean position, if I give a small displacement, it can be approximated as SHM and we can find the time period, provided there's no non-conservative force, okay, only the internal conservative force is acting. So what we do is from this we convert to force. So F is minus du by dx. So we also get F as a function of x. So when we are plotting that F as a function of x, okay, for corresponding sort of points, you can see that where u is having a negative slope, f will be positive. Where, okay, where, so let's say this is the point x1, this is the point x0, the point x2, where there's a local maxima. the point x3, let's say. Okay, so you can see that at the point x1, the force should be 0, but before x1, it should be having a positive slope. So it's the force versus x graph would be something like this. Would be positive here, then negative here, then going from negative to positive here, again going from positive to negative. So you can see why this is an unstable equilibrium point, because there is non-restorative force x2, but x1 and x2, x0 are stable equilibrium points, and so on and so forth. Okay. Now, if we take a small amplitude with respect to x0, that means my range of motion is very small. It is between these 2 points, which is x0 minus delta x to x0 plus delta x. Then whatever that formula of that force as a function of x between these 2 points, because they're very close, it can be approximated as a straight line. So F is approximately a straight line with a slope which is basically df by dx at the point x equal to x0, and that will be a negative slope. Okay, so that is your effective minus k. So your F is becoming minus k of delta x, a small displacement with respect to that point. Okay, so your SHM omega square is equal to k by m. So it is basically magnitude of that slope at that point x0 divided by mass. That's your omega square. Okay, so is this general concept clear, Prachi?
Yes, sir. Now it is clear.
So कोई भी potential energy function or graph is given to you, and with respect to any one of the mean positions or the stable equilibrium positions, you want to find time period for small oscillations. You have to convert the potential energy graph to a force graph, and with respect to that stable equilibrium position, if you take a small range of motion, then in that small range of motion, the forces curve can be approximated as a straight line, which has this kind of slope. And from that slope, we can find the effective time period. So this is the general method. Okay. I'm moving on to the next question. So beta, your next question is also a similar type of thing. Okay. Particle moves, particle moves according to the equation F is equal to minus AMR, where A is a positive constant, R is the radius vector. So it's basically position vector. Okay. Which is R naught I cap and V is equal to V naught J cap at T equal to 0. Describe the trajectory. Okay. This is a little bit more complicated. Okay. Let's understand this question. It has two-dimensional motion. I think one of the components will be, both the components will be SHM basically. It's a combination of what we call orthogonal SHMs. Anyhow, let me explain. So we have this equation given, which I'm now writing in vector form. Okay. So it is minus AM into R.
Which SHM you said?
Sorry, come again, beta.
Which SHM you said? Orthogonal, right?
I'll explain. Okay. Let me come to the question. Okay. So the force, we can write AM as some effective K. So the net force acting on a particle is like this. It is minus K. If it is two-dimensional motion, we'll write the position vector as x I cap plus y j cap. Okay. So we have basically two distinct equations, that Fx is equal to minus Kx and Fy is equal to minus Ky. Okay. Or we have m d2x by dt square is equal to minus Kx and m d2y by dt square is equal to minus Ky. So from the first equation, you will see that d2x by dt square is equal to actually minus ax, and d2y by dt square is equal to minus ay. So this will tell me that its x coordinate is some amplitude, let's say a1 sine omega t plus some phase constant phi1, and this will tell me its y coordinate is some amplitude a2 into sine of same omega t plus some phase constant phi2, where omega is square root of a. Okay, so clear so far, Prachi?
So I didn't understand that. Can you explain again?
Okay, so the question is like this. I'm reading out the question once more. It says that a particle of mass m moves according to the equation F is equal to this, where R is the position vector in a two-dimensional plane. Okay, so a particle of mass m, it is acted upon by a force like this. It moves in a two-dimensional two-dimensional plane, such that at any point of time, the net force acting on it is given by this. First of all, is the question clear?
Yes, sir. This is clear.
Okay, so this is like a dynamics problem, that it's given to you that the net force acting on a particle when its position vector is r is given by this relation. So I've just converted this to component form. I've written in 2D, your position vector is xi cap plus yj cap, and your force I can write as fx I cap plus fyj cap, where fx will become mass into x component of acceleration. So that is mass into d2x by dt square. And similarly, Fy will become mass into y component of acceleration. So m into d2y by dt square. Okay. So Shikhar, hope this is clear from this point.
Yes, sir.
Okay. So this is the only information given in the question, that at a position vector r, the net force acting is like this. So from that, I have converted to this. Okay. So what I'm showing is that the x coordinate is also varying sinusoidally with time. The y coordinate is also varying sinusoidally with time. Okay. Now the additional information, one more information given in the question is that, so one was this thing that was given. Okay. The other information given is that at t equal to 0, okay, the position vector is actually just r naught I cap. That means the y coordinate is 0. And the velocity vector is equal to v naught j cap. Then we have to find at t equal to t, the relation between x and y. We have to find the trajectory between x and y. Okay. So let's convert this. Okay. So this basically means that at t equal to 0, my x naught is r naught, but my y naught is 0. And this means that dx by dt at t equal to 0 is 0, whereas dy by dt at t equal to 0 is plus v naught. Clear, no? So this will tell me that
Yes, sir.
a1 sine phi is equal to r naught. Okay. And a1 omega cos phi should be 0. From this information here, from this piece of information, I'm getting this.
Yes, sir.
And from this information, I'll get like a kind of reverse of this kind of thing, that a2 sine phi should be 0, whereas a2 omega cos phi 2 actually. Okay. So that should be plus v naught. It's phi 1. So यहाँ से a1 a2 and phi 1 phi 2 मिल जाएंगे. Okay.
Yes, sir.
Okay, so how much is my phi 1 coming? Pi by 2. Okay, and a1 is r naught. So that means what is my x coordinate as a function of time? It is r naught cos omega t. Correct. And
Yes, sir.
from this
Correct. Cos
information, I will get that
omega.
phi 2 is how much? 0. You know? And a2 is v naught by omega, or v naught by root a. So what is my y coordinate as a function of time? My y coordinate as a function of time is v naught by root a sine omega t. Okay, so Prachi, this is clear so far?
So can you explain the relation omega is equal to root a?
वो तो यहाँ से है ना बेटा. This d2x by dt square is minus omega square. That term is a. No? How we got that term is, see, from the equation above only. No? This is your effective k. Na? A into m is your effective k.
Yes, sir.
So k by m is a only. No?
Yes, sir.
Okay, understood. Okay, now how we'll get the relation between x and y? Eliminate t. So use the relation that cos square omega t plus sine square omega t is 1. So you'll get an equation of an ellipse actually. You'll see it has an elliptical path because this is x by r naught square plus root a y by v naught, correct, square is equal to 1. So we are effectively getting this kind of equation, x square by a square plus y square by b square. You've done ellipse in coordinate geometry so far?
Yes, sir.
Yes.
This is an equation of ellipse now. By chance, if r naught is equal to v naught by root a, then it becomes a circle. Okay, special case, capital A is equal to capital B, but in general, it's an elliptical path. So this kind of thing, it is called orthogonal SHM. I mean, combination of orthogonal SHM. Orthogonal means perpendicular. So if we have one SHM which is like this, and a perpendicular SHM which is happening like this, then their combination results in elliptical path. So these two are called, they are orthogonal SHMs because they are perpendicular to each other. The term orthogonal means perpendicular. Now, technically, combination of orthogonal SHMs is not really in our syllabus. We have the combination of linear SHMs like x1 plus x2 like we have done before. But yeah, some of these concepts will come in waves also when we discuss in the next chapter. So that point of view, can understand these things. Okay. So Prachi, I think your doubts are also cleared.
Yes, sir. Mine are done.
Okay, Piyush, question number 15 from HCV. Okay, let me come to that. Give me a moment. So if you have HCV in front of you, just go to the SHM exercise and go through question number 15. We will discuss. SHM comes after gravitation, if I'm not mistaken. Yeah. So question 15 is that SHM on a this thing inclined surface kind of concept. Yes, Prachi, I will forward the notes and the recording of both the previous class and today's class immediately just now. Okay. So we have these two blocks which are kept on an inclined surface, and the spring constant is given to us like this. Okay. And we give it a further push from equilibrium. So we have to find the speed of the blocks at the time of separation. Okay. So Piyush, first of all, what we have to understand in this question is that if I compress it, the spring further or push the blocks down further from the equilibrium position, then at what stage will they lose contact with each other? So let me begin by drawing the equilibrium position. Suppose this is my equilibrium position. This spring is attached to this block. And this block is not attached to this, it's just kept against this. So this is my equilibrium state. So what is the equilibrium position of the spring? We'll have a compression of the combined weight into sine theta. The tension in the spring should be that much. Okay, so Piyush, this part is clear.
Yes, sir.
So m1 plus m2 g sine theta by k, that is my equilibrium position.
Yes, sir.
Now from here, the question says that I have compressed it further by twice of this value, no? And released it from rest. So now I have taken it this by
2m
mg
m2.
by 2. So had this been a combined block, this would have been the amplitude of SHM. This would have been
सर तो उसको रिलीज भी किया तो मैक्स टू मैक्स वो इधर तक ही जाएगा बिकॉज हम लोग ने वहां तक ही स्ट्रेच किया उसको, राइट?
but that would be the case better if the two blocks were attached to each other. You understanding the point? But at some stage, what can happen? They can lose contact.
Yes.
So will they actually reach this point over here on the other side without losing contact? No. The question is, when do they lose contact? Okay, so this is what you have to think carefully. At what stage the two blocks will lose contact? Okay. Now tell me what happens that if this is 2 mg sine theta by k, somewhere in between is the position where the spring reaches the natural length.
Yes, sir.
Okay, so this is where the
equilibrium
x becomes 0. Equilibrium के बाद होगा बेटा, because equilibrium पे तो mg sin theta by k है ना.
Okay.
So see what is happening at this position. What is the x of the spring? It is 3 mg sin theta by k, and it's a compression of this much.
Okay, so initial
at equilibrium
plus compression.
Sorry.
The initial position plus the compression.
Yes. Okay. Now, if this is the position where x is equal to 0 for the spring, okay, then after this is a position where there is extension. Okay. Now think the moment the spring gets extended, what happens to the block M1? It's getting pulled by the spring, no? So can it remain in contact with M2? No, no.
No.
Okay. So this is when the system loses. So it reaches here at some time t1 because you started from here at time t equal to 0. Okay. So when it reaches this position, the blocks lose contact. Okay. So that position is basically with respect to my mean position. It is at what position? It is at x1 equal to plus mg sin theta by k. Or we'll write that as the displacement from mean position instead of this one. We'll write that as the displacement. At displacement of this much, they lose contact. Whereas what is the amplitude? It is 2 mg sin theta by k. Okay. And what was your initial position? It was minus a. Okay. So given initial position is minus a, your s as a function of time will be what? It will be minus a cos omega t. Okay. So at the time t1 when they lose contact,
Sir,
should become plus a by 2. Yes.
the initial position will be a by 2, right? Because agar initial position like m1 plus m2 g sin theta by.
No, beta. See, m1 plus m2 g sin theta by k is the mean position. But from that we are compressing it by 2 mg sin theta by k further, na? So the net. So that is your initial position, na? T equal to 0 पे तो वहाँ पे.
Okay. तो वो
starting from the negative extreme, na?
3 mg sin theta by k हो जाएगा.
Yes. Okay. So at t equal to t1 when they lose contact, this is what is happening. Okay. So your position is going from minus a to a by 2.
Yes.
So what will be the time taken? The time t1 will be now to go from minus a to 0. The time is 1/4 of the time period, and then to go from 0 to half the amplitude, it is how much? 1/12 of the time period.
Sir, can I repeat again?
0 to half जाने के लिए कितना time period होता है? So to go from 0 to half, your phase angle has to change from 0 to pi by 6, na?
Okay.
Your time has to go from 0 to t by 12. So this is the time, okay. And what about the speed? V1 at that point of time will be a omega sine omega t. You can see from this also.
Yes, sir.
Okay, so this is what has been asked now. So it will be that amplitude, which is 2 mg sine theta by k into omega. Now omega for the system is what? It is square root of k by m1 plus m2, okay, into sine omega t. Now see, cos omega t is minus half at that point of time. So sine omega t will be how much? Root 3 by 2.
Yes, sir.
So this is the easiest way of doing the question.
Sir,
Yes.
तो पीछे आंसर दिया है like HC1 में कि पीछे कि it is when the spring acquires its natural length. That time the blocks will separate, sir.
Yes, so that's what we have done. No? Spring is at natural length only. No? That is when the position with respect to mean equilibrium point is how much? It is a by 2. No?
Okay, okay.
Look at this diagram again. No? Mean position पे actually क्या हो रहा है? मेरा spring का compression mg sin theta by k है. You know?
हाँ.
Right now? So
Mean
if this is your mean position,
हाँ.
here it is mg sin theta by k compression. Okay. Now on this side you have your amplitude from where you started. This is your amplitude. Here the compression of the spring was 3 mg sin theta by k.
Okay, okay.
That is why your amplitude came out to be 2 mg sin theta by k. Na? Now instead of going all the way to the top, it's not able to go all the way to the top because when it reaches the natural length position of the spring, that is when it loses contact. So that natural length position of the spring is where it's at a by 2 from the mean position. Understood? Na?
Yes, sir. Sir,
Yeah. Yes, you had some question?
sir, I was asking कि अगर ऐसा ही अगर 2 ब्लॉक रहे अभी, अगर सपोज 3 ब्लॉक रहता तभी भी नेशनल लेंथ पे ही अगर उनका रिलीज होता, राइट?
Yeah, I mean, whatever the number of blocks, na, only one of them is attached to the spring. Na? So the moment the spring starts pulling that block back, it cannot push against the other two.
Yeah.
Okay, so in that case, the other two would move together, but they would lose contact with the first one.
Okay, yeah. So same natural length पे they lose.
The other two would lose contact in such a way that the normal reaction between them would be zero, but they would be moving together.
Yeah.
Understood? Na? Kinematics wise, they'd have identical kinematics.
Yes.
With an acceleration of g sin theta.
Yes. Understood. Yeah.
Okay, good. Yes.
Block 1 and 2 will lose contact, but the larger one which is still connected to spring will also move, no?
हाँ, so वो ज़्यादा decelerate कर रहा है ना compared to the upper one.
पर फिर भी आगे तो जाएगा ना?
हाँ जाएगा ना. So that will continue in an SHM, in a different SHM now, because its effective time period and all will change.
Yes, sir.
You understanding? And
Yes,
at some states, all this will change because the one which has lost contact, it would decelerate, go stop, and then start sliding down the incline plane. So eventually it will come back and hit this one. But then that becomes very complicated to predict, like when it hits, what kind of collision happens. So this is just we are talking about at the instant when they lose contact.
Okay, sir. Thank you, sir.
Okay. So, okay. So you have like what now tomorrow to prepare for the test coming up. Okay. So if there are any last moment doubts, just drop me a message. Let me know. Okay. All the best for test on day after tomorrow. That's it for today, people.
Thank you, sir. Have a nice day.
Thank you, sir. Bye, sir.
Same to you, people. Have a nice day.